Hello everyone, and welcome to my channel. Recently I started to develop an open source project named Async Forge. It provides some asynchronous tools to deal with the Tokyo crate in Rust. So the project is fully written in Rust. I already published three different crates. So there is a Task Forge, Notifier Hub, and Smart Channel. And in this video, I'm gonna go through the Notifier Hub crate and explain how it works, do like a presentation, and also after we're gonna dive into the source code, uh, and I'm gonna present some functions. And finally, we're gonna solve an issue right here, uh, precisely this one, destruction waiter. Uh, okay. So first, what is Notifier Hub? Notifier Hub is a data structure allowing you to handle thread communication in a very efficient and flexible way. Uh, so let's take a look to an example. For example, here, uh, what what does this code do? This example is very simple. It doesn't even involve a thread. Uh, so you can create a hub, and you can subscribe to a given channel. So it's a subscription system. So here, for example, I'm subscribing to the channel one. I This channel one is totally arbitrary. I could provide the strings that I want. Uh, and then yet again, I'm subscribing a second time to the same channel. So here the hub contains two subscribers for the channel one and only has a single channel, the channel one. Then eventually I can build a message and send this message to the hub. I have to provide the message here and a channel, and it will give this message to all the subscribers of the channel. So, for example, here, receiver 1 and receiver 2 should receive this message here. Uh, Everything is based on the Tokyo crate, and here particularly the sender receiver of the MPSC namespace. Uh, so and So receiver 1 and receiver 2 are both two Tokyo receivers returned by the subscribed method of the hub. And so receiver 1 can call its receive method to receive the message that have been sent by the right here by the hub. And receiver 2 also, and both should receive the message sent here. So this method is clone send. I'm gonna explain why it is not simply send. Uh, okay. Okay, let's go to the API overview. So this one just creating a hub, and this one is subscribing to a given channel. So for example, in this example, we are not providing channel one as right here, but channel ID, but it does in reality the same job. It's not just the same ID. So here is how you send a message. So it's the same thing that's here. But here it's a bit different because we are not sending the message with clone send, but with arc send. So why? It's because this one require message to implement clone to broadcast the message through the subscribers. So basically, imagine you have like 10 different subscribers. We're gonna send the message to the first one, then send a clone of the message to the second one, etc., etc. And then all will have 10 message, all gonna own the 10 messages. Here it's a bit different. So here I have a very, very, very huge data, uh, and I want to broadcast it to the subscribers of the channel here. So to do this, I'm using arcsend. I'm giving the ownership of the message, then it's gonna wrap it into an arc pointer, and give the pointer to each subscriber. So each subscriber will have access to the message, but will not be able to modify it, but can read the message. Uh, but the message appear only once, and they are all reading the same. It's why they can't modify it. Uh, Also, you can unsubscribe, like right here. You just have to provide the ID of the channel and the receiver. So for example here, I'm subscribing to the channel 1, and it returns me receiver 1. I'm subscribing yet again to channel 1 and it returns me receiver 2. So this channel has 2 subscribers. Eventually I could call the unsubscribe method by passing channel 1 and receiver 1 to unsubscribe receiver 1 to the from the hub. So hub will take the receiver, will go for the senders binded to the receiver and remove all the senders. It's like if it removes the subscriber from the list of subscribed people. And it's basically what the unsubscribed method does. It returns the results because, for example, if you're just not subscribed, it will throw an error, or if the channel is not ready, etc. Yeah, you notice that the subscribe method can't fail, by the way. Uh, okay, this one is cool also. You provide an ID and it returns you an enum representing the current state of the channel, the provided channel. So running means there is some subscribers, uh, at least one. Over initialized is basically the state of the channel here. So the channel is initialized once someone subscribed to it for the first time. So it means that there are not a fixed amount of channel. You can initialize as much as channel as you want. So for example, when you're initializing the hub, there is no channel. Here, once I subscribe for the first time on the channel 1, it's creating a first channel, channel 1, with 1 subscriber, receiver 1. Then I'm subscribing again, but it's a new subscriber. It returns a new receiver, and there are no 2 different subscribers. And so uninitialized means the channel doesn't have a single subscriber and never had a subscriber. It doesn't exist. Over means once there was some subscriber but not anymore. All the subscriber called the unsubscribe method right here. That's basically the channel state, what channel state method does. Here comes the interesting parts. Um, so the git creation waiter returns also a receiver, but it's a bit different. For example, this receiver will not receive message, but more like notifications. You're gonna receive a notification each time someone subscribed to the provided channel. So for example, here I'm asking for a creation waiter for channel 1, like here. And so when someone subscribed to channel 1, so for example, this guy here subscribed to channel 1, I'm gonna receive a notification, like yes, someone subscribed. Unfortunately, you're not able to tell who subscribed. Uh, it's an issue, and there is some ways to do this, uh, but it's not implemented yet. But it's still very useful. So, for example, if you're dealing with a model where there is only 1 subscriber per channel, you can be sure that the subscribers that has been connected is a good one. Um, it can be used, for example, imagine you want to send a message to another thread through the hub, but you're not sure that if the channel is not initialized yet. Maybe you want to send it, but the thread is not ready yet to receive the message. So to do this, you check first the state of the channel, and when you see this is uninitialized, you're asking for a waiter. You're asking for a waiter, and then when you have the waiter, you're just simply waiting for someone to subscribe, and when someone subscribed, here you know that someone will be able to receive your message, and you can call the clone send or arc send method on the hub. That's basically the point of this concept. Uh, you can also subscribe to multiple channel in in a time. It's like some syntactic sugar. It's not very important. Maybe I should add an example in the README regarding the waiters, like to give an entire example, maybe with some threads to explain why is it worse. Okay. So that's for the API. I think I didn't talk about this actually. Uh, Here, maybe you noticed that the send method is not asynchronous, and it's a bit weird because the send method on the Tokyo senders is asynchronous because it waits for the channel buffer to, if the channel buffer is full, it waits for the buffer to be emptying a bit, enough to place the message in the queue. Um, so the send operation is asynchronous. But here you do not have to put a little await here. So because clone send and arc send also put the send operation in background and returns the handler. The handler provides a wait method right here, allowing you to to wait for the send to complete. So, for example, the handler here contains all the sending operation. Here we are broadcasting this message to the subscribers, which are receiver 1 and receiver 2. And when we are waiting for the sender of receiver 1 and the sender of receiver 2 to send their message. It doesn't mean obviously that receiver 1 and receiver 2 receive this, but like they can receive it. It's a bit different. So that's basically all for the interface parts. We're gonna take a look to the source code. Um, I'm gonna not gonna dive into very difficult things, I think. So that's here. Okay, so that's basically the code of the notifier hub. Uh, and here is the hub, for example. Here's the hub. So the hub, is this guy. So that basically the hub is simply three fields. I'm not gonna talk about this one, but I'm gonna explain senders and creation senders. But first of all, maybe you noticed that there is uh, two generic types here. The first one is a bit obvious. It's the message that's being sent through the hub. So, for example, if I return here, um, I'm providing here a static string. But maybe like I don't want to just send string. I want to send like for I don't know maybe some points like two numbers through the hub. So it's possible because it's generics. You can send the message that you want, but it should be always the same message type. It's not limited because like you know you can deal with an enum for example to cheat and send different kind of messages among the subscriber. The other one is less obvious, is it's the type of the channel identifier. So right here I'm providing a static string, and yet again, both generic types do not have to be the same. But here I'm providing a static string, um, but I could provide, for example, a use size. So here the type of channel ID will be a static string, um, but it could be whatever I want as long as it implements hash and equal. Um, and this is because basically we are dealing with hash map in the for the senders. Uh, it's like the easiest way to do this. Uh, we are binding the IDs with a vector of senders. Message sender is just a type alias here. Uh, it's not very important. So basically here we have a channel ID. And like for each ID, we have a vector of sender. And the sender are the ones that are bound with the return receiver. So for example, when I'm calling subscribe, I'm like building a receiver and a sender, both bound together, and I'm keeping the sender and I'm returning to you as a receiver. And so when I receive a message, when someone call, for example, the clone send message with the clone send method with the hub, I can provide you the message because I have your sender. That's basically how it works. Um, And it's basically the same for the creation senders. The creation senders are binding channel ID with this time a vector of creation sender. Uh, Creation sender is like a notifier, so it's not generic. We are just providing unites. Because the fact is, we are not interested in the actual data that we are sending, but more in the fact that we are sending. It's like it's just a signal. It's just a signal. You don't have to give some metadata. In a future version, maybe it should be cool to provide some information about who subscribed. But it's not the topic of this video. But is- an issue is opened about it. So if you want to try to implement it, you're welcome. It's very interesting. So that's basically how it works. So we have two hash map, simply binding each channel ID with a vector of sender. So let's take a look to, for example, the subscribe function. It's exactly what I said earlier. It basically creates a sender and a receiver, and it's inserting the sender in the map, in the sender map, and returns a receiver. The receiver just here. Insert sender basically just takes the map, the sender's map, try to get the ID. If it exists, it pushes the sender in the current vector. Otherwise, it's inserting a new vector containing the lonely sender. And then it calls the notify creation, which gonna broadcast a notification to all the waiters. Because yeah, we are here at this point, we are inserting a new subscriber, so we should um, tell to the waiters, the creation waiters, that yeah, there is a new subscriber. Okay, so that's it for the subscribe function. Yeah, but I'm gonna talk about unsubscribe right now. This one is a bit more complicated, but it's not no, it's not complicated. So you give the maybe I should oops I should return here. So here you'll give the ID. Uh, Yet again, it's channel ID, it's generic. I could provide a usize. And you give a receiver. So it should be the same receiver that the hub returned to you here. It should be the same. Uh, mm, Otherwise, it will be like some unexpected behavior. It's probably gonna throw you an error. Probably. It's sure. It's gonna throw you an error for sure. And what does it do? What does it do? It's first matching the current state of the channel. If the channel is over or is initialized, then it returns an error because it means like there is no subscriber in the channel, so you can't unsubscribe from channel where there is no one. If it's running um, otherwise, it first checks if you are well subscribed to the channel by using the isSubscribe method provided here. If you're not, it returns an error. Otherwise, um, we take the senders and hash map, and it retains only the senders bound to the given receiver. Uh, so here, for example, like it's the retain method retain only the ones that are satisfying this condition. So the condition satisfied is you're not bound to the given receiver for each sender. Is bound to is a custom method. It's basically I'm not using directly Tokyo channel. I'm using the one that I built in Smart Channel. So I'm gonna talk about this traits another day. It's like a wrapper of Tokyo channels allowing you to check if a given sender is bound to a given receiver. It's basically what I'm doing here. And then at the end of the day, I'm returning the channel states. And so that's cool. Uh, Last thing, and then we are gonna dive into the implementation parts. The gets no, not the get sender, get creation waiter. Get creation waiter is quite simple. It's like just basically we are your so get creation waiter is this right here. So it allows you to be aware of where when someone subscribed. So it sends you a notification when someone subscribed. So to do this, you're just giving the channel that you want to follow. Um, so it's here. We are building yet again a sender and a receiver. we are returning to you the receiver, and we are keeping in the map the sender. It's like the same pattern everywhere. Okay, so that's cool. I think we are gonna dive into the implementation. I don't know if I forgot something important. Uh, no, I think no, it's not very other functions. It's always basically the same. Uh, okay, so let's. I would like to implement the destruction sender. So basically, we have senders. We have a system like a creation sender. When someone subscribe, it sends you a notification. I would like to do the same, but for the destruction. So when someone call unsubscribe, we are sending to you a notification. Um, so it will be quite similar with creation senders. Uh, I'm gonna do it in two parts because I have another idea behind it. I'm gonna show you after what what I'm gonna do. But I think at the beginning it will be quite exactly the same. Um, so let's try to go through it. So the idea is when a subscriber call the unsubscribe method on the hub, uh, what we are doing currently is simply just removing the sender and dropping it. Now we would like to also send a notification to the destruction waiters. So it will be exactly the same. We will have to like to store, I think, an hash map, binding yet again a channel ID with a vector of sender. So, but this time it will be like destruction senders, and here it will be destruction senders. Um, okay, so let's go. So we have to define. So it will be a public type, and it will be basically the same as this one. It's like it's just notification senders. So yeah, for now it's quite similar as creation waiter, um, but it's fine. It will change in the future. You will see. Because I have an idea to this properly. Okay, so and here, so yes, obviously, sure I have to add this. It will be an hash map. I should do call default here. I don't know why I'm not calling just default. Okay, it doesn't matter. Okay, so I have destruction sender. Yeah, I have a warning here because I'm not using this guy. No, it will be in the unsubscribe method. So here, basically, there is three ways to unsubscribe. The first one is by calling unsubscribe, obviously. The second one is by calling unsubscribe multiple. It takes a channel, an array of IDs, and then it calls unsubscribe for each channels. So basically, when you're calling a subscribe method, at the end of the day, the only moments when you are removing something from the sender's hash map, it's here. So this one is like in relation with this one. And the last one is unsubscribe all. So you're giving a receiver, and it unsubscribe from all the channel that the receiver is in. So here I'm just getting the subscribe list. So subscribe list returns the list of the channels that you are subscribed. Uh, and if it's not empty, I'm unsubscribing for all the channels, and I'm ignoring the error. Yeah, this should not fail as subscribe list returns only valid channels. So actually, I just have to change this part of the code since that's the only moment when I'm removing someone. So I would like to. I have a function notify creation. I think creation. Yeah. I'm gonna copy and paste this one. I'm gonna put it here for now, and it's gonna be notify destruction. Notify destruction take the hub as mutable. Uh, why do you have to take it as mutable? Oh, let's go. I think in the previous version I was modifying this, so but I forgot to remove this. So yeah, I don't have to take you as mutable. So it's taking this as mutable. Then it's matching on destruction senders, and uh, it's and that's it, I think. Yeah, that's it. We don't need to do something else. We just want to broadcast notification among the consent senders. The writing handler gonna handle the writing operation. That's basically it. So we just give him the list of senders, the message. Here the message is unite. It's why we are cloning using the cloned broadcast method and not the arc broadcast method. It's because we can clone a unit type, obviously, and then it will like assure that all the message has been put in the queue. And then I can call, for example, unsubscribe. Here I can call self dot notify destruction with the ID, and it works. So it basically all that I wanted to do for destruction yet. Uh, is only remaining is obviously get destruction waiter. So it will be yet again exactly the same, but for destruction. So we are providing an ID. We are providing an ID. It returns a destruction waiter. It created channels. Then we are matching on the results of the getMut method on the destruction senders map. If it returns something, I'm inserting, I'm pushing. Otherwise, I'm inserting something new, and I'm returning to receiver. Okay, I think it works. I'm not gonna implement the like the test function right now. Yeah, I have a bunch of test function right here. Um, but let's by the way test if we broke or not the application. Normally it should be okay because we didn't notify cargo test. It seems to work. Let's go. Uh, but the thing I want to add, it's okay. Maybe you're wondering, is it very useful to provide this feature? Because okay, if you're waiting for the death of another thread, that's the death of a subscriber. Why this information could be useful? So yeah, it could mean that the thread is over, but you don't have any information of who dies. So it's basically the same problem at creation senders, and it's useful. But I think we can enhance this by providing some information in the destruction senders. So what I came up with was to send the dead senders. Maybe it's a bit bizarre, but when we are when we are unsubscribing, the senders that we were keeping in the map is dropped. It's just simply dropped. The idea here will be to to keep the sender and to give it to the ones that are subscribed to the destruction waiter. That's basically what I want to do. So here I'm gonna provide a sender. It's gonna be like a dead sender. I have to introduce this. Is this gonna be yeah, it's gonna be a public type, I think. Yeah, yeah, it's gonna be a public type. Dead senders. This one has to be generic, so, and it's just gonna be message receiver, a message sender M. It's just gonna be this, exactly the same, because I'm providing the same message that the senders that I dropped. Just I'm putting a name to because it's clearer in my opinion. And so here I'm providing a dead sender, the sender M, and yet again dead sender M. And so just see, I want to make this generic. So here we are introducing no. What are you doing? Okay. So here we're introducing a new generic. So of course it's gonna be M, I guess, because it's the same kind of message. Okay, and we have, let's go through the compilation error. So the first one is here, notify destruction. So of course, here I have to provide a dead sender and not a unit type anymore. So it will be dead senders, and we will pass it in parameter, I guess. This one is called by unsubscribe, and we during the unsubscribe we're retaining and we're removing the concerned senders, so we are gonna pass it here. Do I have to take? Okay, we'll see. Um, we're gonna take a reference. Oops, it's not what I wanted to do. Dead sender. It's gonna be a reference to a dead sender. Um, because cloning broadcast takes a reference of M. So yeah, should do this. Why? Yeah, it's because here I'm providing unites again. It's dead sender. Okay, and it doesn't work. Oh yeah, I know what is going on. So this function is basically in a block when M doesn't require to implement anything. Uh, but like you see, the clone in broadcast is cloning the sender that I'm providing. So the dead sender M should implement clone in this case, but it doesn't. So I'm gonna put it in another block when M is implementing clone. So not this one because it's not implementing clone. This one, for example, is implementing clone. So it implements send, static, and clone. Oops, thank you, Emacs. What did I put? Maybe it's here? Yeah, it's here. Cool. Is it complaining? No, it's not complaining anymore here, but I have some error here. Yeah, because unsubscribe now calling notify destruction without providing the sender. So I have to get the dead sender somehow. Um, how am I gonna do this properly? It is retain. What is retain returning? If we know the boolean, what is it returning? Okay, so it doesn't return like a vector of things that have been. I could start by finding. Yeah, maybe I'm probably gonna do this for now. It's not very clean, but I could like do senders iter dot find oops s dot is bound to, and the receiver we passed in parameter here. So here we are providing a receiver. I'm simply finding the corresponding sender, and then I'm notifying the destruction by passing the dead sender. And why are you complaining? Yeah, there is two problems. Okay, so here yet again this function is not in the good block, and moreover I think here I'm gonna have some issue with the borrow checker. Yeah, for sure. Where is my? Uh, is it here? No, no, no. Where is the? Ah, it's here. I have to put it here because it's this one required to implement clone, so this one should also implement clone. And here it works. Yeah, it's because I have to unwrap. I can unwrap. Maybe I'm gonna replace it with an unexpected error. But I can unwrap since I checked here if some of my channels were, um, if some of my channel were like bound to me. Some of the senders in the array were bound to me with the subscribed method. So I can unwrap. I'm sure that somewhere there is my sender. And here I have some issue with the borrow checker. Yeah, it's because here, yeah, I'm borrowing, so I have to clone here. Yeah, I have to clone, and here I have to pass it as a reference. Okay, so it seems to work. It seems to work. Okay, next error. Unsubscribe multiple. Okay, this one is not difficult. I just have to put it. I guess it's it. It's because it's complaining because it shouldn't implement clone. Yeah, it's simply this. I'm gonna take at the same time the unsubscribe all. Uh, where is it? Where are you? You're here. I'm gonna put you here. Yeah, so I'm dividing the code in multiple blocks. For example, this one require M to implement send, clone, and static. Send and static are required because should implement, sorry, clone, send, and have a static lifetime. Static here means it should own the thing. Um, this is required because we are cloning and sending through threads the value. And here, for example, with the arcsend, clone is not necessary, but sync is necessary because we are sharing a shared reference through the threads via the arc. Okay, super. So and now it's good. Why is it complaining again? Get destruction waiter. So now it's generic. I have to put M here. Hmm. Get destruction waiter. Yeah. So here it should. What is destruction waiter? Yeah. What is going on here? It should work. Ah, it's because I'm like you see, it was creation waiter and not destruction waiter. Yeah, it works. Nice. And we don't have any more some errors. Okay, that's cool. Did we break the app? Let's make a test. I think no, because we yet again we didn't modify the important things. Okay, cool. So it was quite easy. It was quite easy. I didn't expect to do this that fast. But okay, it's fine. What we're gonna do? We're gonna first of all write a test function, uh, and it will be the equation to like to show how does it really work. What I'm probably gonna copy and paste. Yeah, I'm gonna copy and paste the test unsubscribe function. Yeah, this one. I'm gonna copy and paste this. So what does this test does? It creates a hub. It will be test get destruction waiter. What does this do? So we are basically creating a hub. We are subscribing a first time to channel 1. Then we are unsubscribing to channel 1. We are checking if it succeeds. I could just unwrap. Yeah, I'm simply simplify this by unwrapping. And then we are verifying that if the new state of the channel is over, because it should have changed. And maybe to if I want to strengthen the test, I could put this here. This should be running. So in first we are subscribing, and even if I want to do this, voilà, it's the best way to do this. Okay, so first the channel is uninitialized, then I'm subscribing, so it became running, then I'm unsubscribing, so it became over. And that's cool. It should work. Nice. And so now I want to deal with destruction waiter. So I want to start by getting a destruction waiter. I'm gonna call the hub.get get this. Why the completion is doesn't work here? I have to provide channel 1. Nice. It should be mutable, by the way. Then here, okay. This one doesn't need to be mutable. After I'm unsubscribing, so I'm able to receive the dead sender. Yeah, that's it. I can receive the dead sender by doing this. Why? Emacs destruction waiter dot receive dot await, and I guess unwrap. And so I have normally first the dead sender should not be closed. it should not be closed because like this receiver hasn't dropped at any moment. It's still live. It just unsubscribed from the hub. So it should not be closed, and moreover, it should be bound. Um, it should be bound with like the receiver. I think it's a reference. Okay, so let's test. Nice. It seems to work. So let's outline, and then we're gonna do the final test. We're creating a hub. We are asking for a destruction waiter. Then we are subscribing. We are unsubscribing. And then so the destruction waiter should get a notification indicating that yes, someone unsubscribed and should return the sender. The sender uh, is not closed and is bound to the receiver. Then uh, this this test is not necessary. I'm gonna remove it. Oh, let's this one just testing if I'm well unsubscribed, you know. So if I try to unsubscribe a second time, it should return like yeah, you're not subscribed. I'm gonna let it here. Um, but no, I should do be able to do this. So I can do daysender dot send, and I can provide whatever I want. What type is it? It's a string, I think. Yeah, so I can provide string. So I'm gonna do like let dead message. Gonna be a new string. For example, hey, you are dead. And I can provide a dead message. I'm gonna await and even unwrap. Oops, I'm not gonna do like this. I prefer. And so the receiver should be able to receive the message. So receiver dot receive dot await dot unwrap should be equal to dead message. And so yes, yes, it has to be mutable. And yeah, whoa, yeah, I'm stupid. I have to clone here. Okay, that's good. That's very good. Okay, so now I can test. Normally, as they are both bound, it should work instantly. Okay, nice. First try. So it's cool. Destruction works. Um, I I could cut the video here. No, I'm gonna try to factorize some function, and then I'm gonna cut the video. Uh, for example, no, there is a last function. I think get number of waiter. I think number of creation waiter. Yeah, I have to do the same for the destruction. Yeah, but here there is a lot of repetition. So I'm clearly gonna so for destruction it's gonna be the same. So the thing that changed is here. Okay, so those methods are basically the same, but not on the same hash map. So I could like do a more general function, or I could do a macro, but the macro is a bit overkill. Yeah, okay, let's try. How can I do this? I will have to. Yeah. Um. Is it possible? No, I think it's not because. Ah, yes. Yeah. Okay. Oh, so for example, if I do this, it returns a new size, and yeah. Okay. I think it takes an ID and it takes a map. Takes a map, and the map is basically an hash map binding channel ID to T, and T is here. Uh, and so I can just copy and paste this here, and here just not like ID. No, it's map. What? Yeah, it's map that gets. Uh, oh, yeah, I can do this. Yeah, I can do this. I absolutely can. Yeah. So here I'm asking that the hash match should be binding a channel ID with a vector of t, and t is passed here. And so I don't even have to get self here. Yeah, I think it works. And so I think I can do like self get number of waiter with this in parameter, not this. It doesn't work. Yes, because I have to provide the ID too. Hmm. Yeah, I have to put your reference here, obviously. Okay, it works. It works. Up here, I can do exactly the same, but just providing here. That's a very good thing with generics, and here it's destruction waiter with a T. So that's basically it, and I think I could do like for the get creation waiter, maybe I can factor like have a function pub no not pub a private function get waiter taking basically this and a map, this time a mutable map that binds channel ID with T, and T is yet again generics, and it should return. It's not that easy. Because creation waiter and destruction waiter here are a bit different. Yeah, but I can do introduce a private type waiter. Yeah, I'm gonna introduce a private type waiter that takes M, that is equal to this, um, but with M here. And I guess I will have to, how can I call it? Uh, this one is like a receiver, and this one should be a sender. So notifier, maybe. Yeah. So get waiter. It should return a waiter. It's like totally generic of M actually. T, sorry. Yeah. And to do this, we can simply do that. Oh, what are you doing? I think I did something wrong. Okay. So we're gonna change because here it's map. Here yet again it has to be a vector of t. What's what's the matter? Yeah, I have to indicate that this is a vector of smart sender. Uh, it's like a sender, sorry, of t, and yeah, but it's basically just my notifier waiter with t. Why are you complaining? Because here I didn't, yeah, map. Okay, so it works. Let's read it again. So I'm providing an ID, a map, and here I'm returning a generic waiter. So it basically does exactly the same thing as here, but I can just replace this one by that. Self dot, oh, okay, get waiter. I hope. Yeah, I know what's gonna happen. Oh no, I think it doesn't work. No, that's fine. This is not the error that I was waiting for. This is a mutable reference. Yeah, but it doesn't work. I clearly know why. Yeah. Because we are borrowing a first time self as mutable here and the second time self as mutable here. Um, I think I can do this, like remove here and provide the ID here. You know, like um, channel ID will be a smart channel ID, and so here I just put channel ID, and right here I can like. Okay, so here I'm avoiding the self arguments by I'm avoiding the self arguments by creating the ID before entering in the waiter. So I can just it's the first parameter. And it's not self, it's self. Nice. Yes, it works. And I can do the same for this. Uh, nice. And it's gonna be destruction waiter. Okay. Did we broke something? No. Nice. Okay, so it seems to work. Um, I could push. Okay, that's very good. Um, I'm gonna stop the video here. Maybe I could factorize something else. I don't know. No, I think it's okay. I'm gonna change the comments for the modified functions, but it should be okay. Okay. So thanks for watching the video. I'm gonna cut here. If you want to contribute to the project, you're welcome. There is a bunch of issues right here. You can try to pick one. I recommend you, for example, this one. It's like I would like to add a single subscriber channel model. So I explained it here. The idea is here you have like you can have as much as subscribers as you want, but it implies that when we are broadcasting a message among the subscriber, we have to clone the message. If we were in a context when we only have a single sender, we could like take the ownership of the message and give the message to the sender, and it would not be an issue anymore. So it's why it could be cool to have another data structures like a single subscriber hub or something like this, and it likes it give it it's not binding channel ID with vector but just with message sender. It could be built on top of this, and it could be very cool to have like multiple hub working in a different way. And then maybe I think I opened an issue about this, uh, something like, yeah, it's this like to add as I have a lot of idea of different hubs. So for example, there is here a wrapped hub um, that is a thread safe, and the idea will be to standardize the hubs by creating a trace with, like, for example, the subscribe method like this, or the notify creation, etc., etc. Okay, so that's all for today. Thank you for watching this video, and I'm probably gonna present this crate in the next one. So if you want, you can subscribe or to follow the advancement of this product.